Hi everyone. In today's lesson we're going to talk about zeros of a polynomial. So let's get started. Now we know that zeros, x-intercepts, roots, solutions of a function can be used to make a graph. We know that these are the points where the graph touches the x-axis. Now we're going to see what we can do with some of the information, and given an equation we're going to find all the information requested for us. Given the function is factored form, we can use these factors as the x-intercepts of the graph because the factors tell us where the y value is 0. So for example, if you have y equals negative 0.5 times x plus 3 quantity squared and x minus 2 quantity, then we can say that x plus 3 equals 0 is one of the answers, and x minus 2 equals 0 is also another answer. Well, we subtract 3 on both sides here, and we get x equals negative 3 as one of our solutions. Now what we notice is that the x plus 3 is squared. Therefore, we have what we say is a bounce. At x equals negative 3, I'm going to come and touch it, and it's going to look more like a U at that spot because it is squared, kind of like a parabola. Now, in the other one, we have x equals 2, if I move the 2 to the other side. And in this case, since the power is 1, which is odd, we say that it's just going to go through. So this will be through. Now, we do like to know what the parent function's name is. And in this case, we count how many x's I have. I have 1 x here. And I have 2 right there because it's squared. So technically that's x times x. And if you don't believe me, I can even write it as negative 0.5 times x plus 3 times x plus 3, since there's 2 of them, times x minus 2. So since there are 3 x's, I know that this is a cubic function. The x-intercepts are what we solve for, and they can be written as points. One of them will be negative 3 comma 0. And the other one is 2 comma 0. But remember that x equals negative 3 technically is happening twice, so I can go ahead and say negative 3 comma 0 again. Doesn't make a difference, but it's nice to have it. Now, is there a bounce? And the answer is yes. Where? It's at negative 3 comma 0 because it is squared. So because it's x plus 3 squared, we know that there's a bounce there. We are going to go ahead and find the maximum, the minimums, and increasing, decreasing, so we'll utilize our calculator for all of this. But for right now, let's go ahead and plot our points. We have an x-intercept at negative 3, 0, and 1 at 2 comma 0. So that's all we know so far. Now let's go ahead and see what it looks like on the calculator. So I'm going to go to y equals, and I'm going to type in the equation that I have. Now if you don't have a graphing calculator, Desmos might be a good idea for you, so try it on Desmos. So we have x plus 3, close it up, squared, and then we have x minus 2 in parentheses. And we're going to go ahead and graph this. Oh, I was using this for another class, so it looks crazy, but I'm going to do zoom 6 just to get a 10 by 10 screen. So here's our equation. This is what it looks like. There are a couple points that I want to find. One of them is a maximum point and a minimum point according to my paper. So let's start with the maximum point, which is right there. We're going to do second trace maximum, which is number 4. And I'm going to do left first, enter, right of the point, enter, and enter one more time. And here's the maximum, 0.3 repeating, comma 9.25. So we'll just say 9.3. So the answer is going to be at 0.3 comma 9.3. So we're going to plot that point, 0.3, 9.3. So here is the maximum. All right, so let's look at the minimum. Minimum looks like it's here. It almost looks like the x-intercept, but I want to check it. So I'm going to do second trace minimum, which is number 3. I'm going to go to the left of the minimum. Here I am left, and I want to go to the right of the minimum. Here I am to the right of it, and press enter again, and we got negative 2.999. Remember, that's the same thing as negative 3. and this is e to the negative 12, that is the same thing as saying 0, because it's technically this decimal moving 12 times to the left, which is a lot of zeros before you even see that 4. Okay, so that is negative 3 comma 0 is our minimum. So negative 3, 0, that right there is our min, which is also the x-intercept. And then we're going to go ahead and sketch our image. So I have starting up high, touches the x-intercept, aka minimum, comes back up, goes over, goes to the maximum, comes back down, touches the x-intercept, and then continues to go down. Okay, so that's what it looks like. And now we're going to do some increasing, decreasing intervals. So we are increasing from the minimum to the maximum, and the rest of the parts are decreasing and decreasing if we are reading from left to right. So what we need to do is just figure out where this is happening. So I'm going to just go ahead and put dotted lines there just to divide them, and that number is negative 3. This one is going through the max, and the x value for the max was 0.3, and then we know that infinity is on the left side and negative infinity is on the right side. So we know in this interval we are decreasing, so that is from negative infinity to negative 3. We know that in the next interval we are increasing, so that's from negative infinity to 0.3. And then from 0.3 to infinity, we are also decreasing. So 0.3 to infinity, we are also decreasing. And we tend to put this U symbol saying kind of like and. Oops, that is the world's worst U ever. So hold on one second. Okay. All right, let's try that again. It's supposed to be a U saying and. And then the end behaviors are as x is going to negative infinity, which is the left side, y is going to infinity because it's going up. And as x is going to infinity, which is the right side of the graph, y is going to negative infinity. So that's what it looks like. So some stuff from back in the day that we want to add in there. All right. So that's example 1. The other examples, believe it or not, will go a lot faster. So let's look at them. It says use the graph to write the equation of the polynomial in factored form. So what we're going to do is we're going to figure out what the zeros are and use those zeros to help us out. Ooh, excuse me. So here is one of the zeros. That looks like that is at negative 3. We have another 0 at negative 2. We have another one at 1 and the last one at 2. So it looks like it's degree 4. So here are the roots. The roots are, there's one at x equals negative 3, x equals negative 2, x equals 1, and x equals 2. And therefore, when we want to put this in factored form, what happens is we're going to have y equals x equals negative 3 is going to give us the factor x plus 3. X equals negative 2 is going to give us the factor x plus 2. X equals 1 is going to give us the x minus 1. And x plus 2 is going to give us the factor x minus 2. And that is our polynomial in factored form. So, awesome job. Let's go on to the next one. Oh, by the way, all of these were through, so I didn't square any of them. Did you notice that? They all have a power of 1, 1, 1, which we don't tend to write very much. So we actually don't write them, but we know that they are there. Okay? All right, let's go to example 3. Now in example 3 it says write the equation of the polynomial with the following roots in factored form. So they are once again giving us the roots for 7 and negative 2. So we're going to write it in factored form. Y equals, well, if the answer is 4, then the factor had to be x minus 4. If the answer is 7, the factor had to be x minus 7. And if the answer is negative 2, the factor had to be x plus 2. So therefore, when they ask us, hey, what is a polynomial in factored form, that's the equation that we give them as our answer. Great job on that. Now, here's a side note, just so you know. What if I said, hey, I have roots that are 2, but it has a bounce, and another one that's negative 3. So in this case, we would have y equals, and the 2 would give us a factor of x minus 2. But since there's a bounds, that means that it has to be like a quadratic, which means even degree. So we have to put a little 2 there. And then the minus 3 is going to give us the x plus 3. Since they're not saying it's a bounds, then we know that it has a power of 1, or at least an odd power. All right, let's look at example 4. In example 4, it says sketch a graph of the following function. So we're just going to sketch it, and the goal is to do it without a calculator. So we have the following zeros. Oh, by the way, remember that if I have something squared, it causes a bounce, which means that at that point, I'm either going to look like a U that's coming from there or an upside down U, depending on if it's positive or which direction you're coming from. All right. So I'm going to go ahead and put the zeros. For example, x minus 1, I know that my answer is x equals 1. So I'm going to put a 1 there. For x minus 2, I know x equals 2. So there's another 0 at x equals 2. And then x plus 3 squared, we have an x equals negative 3. But it is a bounce because it is squared. Okay? So we have negative 1, negative 2, negative 3. And there's going to be a bounce. Okay? Next thing is I want to know what's my degree, and in this case I'm counting the x's. I have 1, 2, 3, since it's squared, 4 technically. So we have x to the 4th power, which means that it's going to look more like a w. And since it either up w or it's going to look like a down w. Since it's positive 0.6 in the front, we know that it has to be positive. It's going to look up, okay? And then what we're going to do is start with the arrow up. Negative 3 is a bounce, so as soon as I touch it, I'm going to come back up, okay? So it looks like a U. Go around. I have to come touch 1, so I do, and I go through it because it's an odd power. And then I turn around and I go through it again at 1, and then I keep going, making it look like a W shape. So that's what it looks like, okay? Remember that x minus 1 equals 0, x equals 1 is the answer. This is through, power of 1. X minus 2 equals 0, x equals 2, that's also through. Okay, but as soon as we saw that x plus 3 quantity squared equals 0, although x equals negative 3, there is a bounce here due to that little 2, that square. All right, I hope this was helpful. Please rewind and watch it again if you feel like that was hard. It's always better to practice and, keep notes and write your own notes as well, guys. Great job today. See you in class. Bye.